Hey everyone, this is my first video on crypto, but I thought I'd just do a quick one to kind of give everybody a history lesson, if you will, in the last 10 years that this stuff's been going on. And just go through some definitions and some of the things you might have been hearing if you're just new to cryptocurrency. Let's get some definitions out of the way. So the umbrella term you've probably heard is cryptocurrency. Currency, self-explanatory, but the word crypto is referring to cryptography. And cryptography is essentially really clever math which can be used to encrypt and verify digital data. First up, let's talk about how people actually send money on the network. You've probably heard these terms before, but cryptocurrency typically uses something called public key cryptography, also known as asymmetric cryptography. And in this case, every person gets something called a public key and also a private key. And you can think of the public key as kind of like the account ID that you have on any service, really. And that's where people will send you money. But the private key that you generate at the same time you generate the public key is kind of like the password. It's the way you can unlock that public key and say that you claim the funds that have been sent to it. A good way to think of this is kind of like safety deposit boxes. And you can create an unlimited number of safety deposit boxes in cryptocurrency. But when you create that safety deposit box, only you have the key that can unlock it. And so people can put as much stuff in that as they want, but only you will be the one that has the key at the end of the day that can go and claim it. So a Bitcoin address, which you've probably heard thrown around a lot, is really just an encoded public key. And it's kind of like a signpost that says, this is how you send Alice or Bob money. And that's all how money is sent on Bitcoin. It's really money moving between different public keys. And because you generated the private key that corresponds to that public key, only you can unlock it. But that's not the only way that cryptography is used in cryptocurrencies. A side effect of cryptography and solving all those complex math problems is that it takes a lot of time and it takes a bunch of computational power. And so that can be used to our advantage in securing the network and making it expensive to try and do something malicious. More on why that's important in a second, but it's called proof of work. Another term you've probably heard is blockchain. So let's break that apart. Now, a block is simply every 10 minutes, in Bitcoin's case, those people sending money from A to B, so from public address to public address. And it's just a bundle. So a block is just a bundle of all those transactions that happened in the last 10 minutes. The obvious problem is that what's stopping people from lying and saying, well, I actually sent this money to this person and this person, but what if I didn't have that money? And so that's where the chain comes in. And the chain means that every 10 minutes, somebody called a Bitcoin miner puts together that bundle of transaction and says, you know what? I want to write this into history. I want to write this to immutable history. Immutable is a word you'll hear thrown around a lot. It really just means can't be changed. But back to the miner. So for the privilege of being able to write that block to the network says, you know what? You're going to have to prove to us that you've done a certain amount of work, because otherwise anybody could just write history. And so that's when proof of work comes in. So the network self-adjusts so that the difficulty takes about 10 minutes to solve a complex math problem. So these miners are out there generating with server farms millions, billions of random numbers trying to guess what they call a nonce. A nonce is just a number. And the first person to successfully guess that number gets the privilege of being able to write that into the immutable blockchain. And you can see how that makes it really expensive for somebody to try and mount an attack on the system. They'd have to have a server farm and waste all that electricity, which costs money, to do so. So one of these miners has solved the problem, and the network says, by all means, go ahead and write your block to the chain. And when they write that block, they don't just include all the transactions that happened and were broadcast in the last 10 minutes. They also include a reference or a hashed version of the previous block. And that's where the chain part comes in, because every new block that is mined has a reference to the previous block. And that goes all the way back through history, hence the chain. And so that makes it really hard to change history, because every subsequent block has a reference to what happened previously. So even if you did get a malicious attacker who came in and said, I'm going to waste all this computational power mounting an attack on the network, they would only be able to change the contents of the last 10 minutes and not of, the past 5 years. In addition to, getting the right to be able to, write to the blockchain, the miners are also rewarded 25 Bitcoin at this point in time, and that scales down over time. But they were awarded 25 Bitcoin every time they successfully mine a block. So you can see the incentives here are really aligned with them being a good actor and not trying to dupe the network in any way. Now, if we're talking different currencies, the variables in this paradigm definitely change between different currencies. But the core concepts that I've just explained really remain the same. Public key cryptography for determining who you are and verifying that you are who you are. And in the case of securing the network, using that proof of work to make sure that the people that are writing history have something at stake and have an incentive to do the right thing. So that's the theory out of the way. And a lot of work was happening from 1998 onwards, but a lot of that was kind of confined to, kind of cypherpunk mailing lists and message boards, and not really in the mainstream. But flash forward 10 years to 2009, and somebody operating under the alias Satoshi Nakamoto releases a white paper and then reference implementation of kind of all these concepts fully realized in a working prototype. And I think that's what was really key, is you could download it, you could run it on your desktop then and there. Very rudimentary implementation and far from what we have today. But that was, kind of the first spark of cryptocurrency being released to the public. Now, a funny piece of trivia that a lot of people don't know is if you actually look in the source code of, I think it's version 0.1 of the code that Satoshi sent to a few people, including Hal Finney, a fellow cryptographer, you see that there was actually a lot more in the UI files that were there. There was actually, the beginnings of a poker lobby and a decentralized e-commerce marketplace with ratings and reviews. All this stuff was subsequently taken out of the code because it's kind of evident that, the key goal was focused on as just being currency. But it's interesting to think, it gives some insights into the original intent of the creator of Bitcoin. They were thinking a lot larger than just currency. So Bitcoin was released to the public in 2009. In the subsequent years, there was a lot of kind of development and community growing, but it was still confined to kind of an enthusiast community. There were several other projects that started to pop up. Things like Namecoin, built on top of Bitcoin, which was aiming at decentralizing DNS, still around today. Another one that's still around today is Litecoin, which simply switched out the hashing algorithm to script in an aim to make mining more accessible to the average, home computer owner. As Bitcoin was taking off, the difficulty of mining was becoming a lot harder, and you couldn't just do it on your home desktop box. So in the years after 2009, there was some development happening, slow but some development. But what you probably remember was in late 2013, there was the big spike. And that's when Bitcoin's price went up to around $1,000 on some exchanges. And that really just brought in a huge amount of media attention, a lot of people starting to invest in different altcoins as well. That's where I come on the scene with Doge Coin, but that's a story for another day. But that was really kind of the catalyst for when there was a huge explosion in terms of people building what are called altcoins or alternative coins that experimented with, say, what if this part of Bitcoin was slightly different. And since then, we've had just a flurry of development. There are hundreds, if not thousands, of altcoins and tokens out there, experimenting with all sorts of things, from just changing simple distribution rules all the way through to running these things called smart contracts, which you can do a whole lot more than just currency on top of. The one that most people have probably heard of is Ethereum, and it's probably the biggest player in the smart contract space right now. They did a crowd sale back in 2014 after Vitalik, the creator of it, released a white paper in 2013. And Ethereum is very similar to Bitcoin in that it is a currency that's powered by proof of work, so there's the blocks like I was talking about. But Ethereum offers a contract system, which is Turing complete. And Turing complete just means that it can do loops and basically execute standalone functions of code. Whereas Bitcoin has a scripting system, basic. It just focuses on transactions. Ethereum is essentially a distributed compute layer. All of this gets run through something called the Ethereum virtual machine. As the name would suggest, it's a virtual machine. You can deploy a contract on the Ethereum network, and the blocks get processed, but every node also is executing the code inside that smart contract. So what does that mean? You can do a lot more than just sending balances from A to B. You can do things like verify ownership. You can have rules around if somebody sends money somewhere, issue them something else. And Ethereum, through this has really seen the creation of a lot more tokens. And they're not altcoins really, but they're tokens which are powered by these smart contracts that are getting running. So they're kind of like a sub coin to Ethereum. So as I mentioned, Ethereum does still operate on proof of work, and that's fine. Proof of work is, a battle-tested, proven way of securing a network. The problem is that as you're running these blocks of code, these functions, it can get quite expensive because the incentives have to be aligned with the miners. So if you're doing something more complex, let's take an extreme example like video transcoding, there has to be an incentive for the people running the nodes and doing the mining to run that over time. And if they're getting rewarded with a very low reward, we call it a gas cost in Ethereum, then they're going to say, no, I'm not going to include that. I'm not going to run that code. So as a result, Ethereum are thinking of switching to something called proof of stake. And there's an ongoing development of that. That's another video in of itself. But this is a common trend you'll see over time as people wanting to get away from proof of work, mostly because it's wasteful. Everybody that doesn't win that block and get to write it to history has just wasted a bunch of electricity and computational power that arguably could be spent better elsewhere. So right now we're in a gold rush, a virtual currency gold rush, similar to what we were in back in 2013. And a lot of that's been driven by Ethereum and smart contracts and people thinking maybe we can do more than just currency. Often when you see the price of these currencies going up and to the right for kind of no reason and at a very exponential rate, it's often indicative of a bubble. And so a lot of people are saying, should I invest? Am I going to get rich off this? It's a gamble. You don't know. But bubbles can actually be good for industries because in a way, when everything explodes, it weeds out some of the projects that didn't have the technical proficiency or backing. It weeds out the people that were just there to make a quick buck. The thing that I think personally is going to really affect this bubble and kind of shape out the next, 3-10 years of cryptocurrency is there's a lot of big decisions that have to be made in the next 12 months around cryptocurrency. The first being whether proof of work is the future or whether we need to switch to something like proof of stake. That's a really big question looming over multiple currencies. Another big problem we're facing is scaling. And so Bitcoin, while it was great back in 2009 because there was fewer transactions, now that people are using it as kind of this financial instrument, there's a lot of money going into Bitcoin. They're having problems with fitting enough transactions in every block every 10 minutes. And so there's a lot of counter proposals, and there's something coming up in August of 2017 that, could potentially fork the network. A lot of big, scary decisions that, frankly, no regular developer wants to have to make and be responsible for the rest of their life. So the decisions that are going to be made in the next 6 to 12 months, I think, are going to be very, very impactful on the state of the entire industry, also the price as a side effect, but also just how we scale this thing into the future and do governance. Who gets to make these decisions? How do you get the whole network to agree that this is the right way to scale Bitcoin? Big problem. And it's going to take a lot of people to solve, a lot of people coming together to solve. So this is the first video I made, but I'm going to make some other videos on topics that I've just touched on in this video, things like smart contracts, the proof of work debate, scaling Bitcoin, ICOs, if you know what they are. And I hope you enjoyed it. I hope it was useful. Let me know if it was. Give it a like, subscribe, and you should see some more videos soon.